Hi students. Okay, now we'll see the working of monostable multi-operator using 555 timer. You can see this is a circuit diagram. Of course, now you know the function of each of the pin. Pin number 8 is VCC, 4 is reset, pin number 7 is discharge, pin number 6 is threshold voltage, pin number 2 is the trigger signal, 1 is ground, 5 is control voltage, of course 3 is the output. As we know that monostable multi-operator is one which has got one stable state and other one is quasi-stable state. So this is the two states. In case of triple five timer based monostable multi-operator, so we have the stable state as 0 level and quasi-stable state as high. So this is actually low and high. When I say low, it is 0 volt. When I say high, it is 5 volt or VCC. So this is the state what we are going to have. Meaning, suppose if you are considering a trigger signal, so if you are giving if you consider a trigger signal, if there is no trigger signal given, so let me just take this as my T. So this is the V trigger. Suppose the V trigger is more than VTL. So now in this case, VTH is equal to this control voltage, so which is equal to 2/3 of VCC. So whereas VTL will be usually half of VTH. It's not usually it is always half of VTH. Now in this case, since VTH is 2/3, this will be 1/3 of VCC. As long as V trigger, this V trigger is greater than VTL, so it's not a trigger signal. If I apply a trigger signal less than VTL, suppose if assume that this is your VTL value, which is suppose if you consider VCC to be 5 volt, then 2/3 of VCC will be 3.33. Then of course, which happens to VTH, the corresponding VTL happens to be 1.66 volt. So if you consider this as 1.66 volts, if the voltage is more than 1.66, it is not a trigger signal. So output will be in stable state. Now you can see this is a stable output, which is 0 as I said here. Now once the trigger signal goes less than VTL, so output goes to quasi-stable state and it remains there for a predefined period, which is a quasi-stable state for a period of T PW. So this is the PW, that is pulse width, which is decided by the timing resistor RT and CT, which is there in this circuit, which is RT CT. Now if you make of course this trigger signal should go back to its state of high as soon as possible, so that you'll get a pulse width of this much. So if I apply one more trigger signal somewhere here, so now what will happen? So wherever it goes less than VTL, output goes higher. So this is what is expected. So let us try to see this. And you can see here, this is the period where it is going low here. So if I say this as T low, time of T low should be far less than T pulse width. So this is the requirement what I am supposed to have. T during which the trigger signal is going low should be very small compared to this, and this T of the trigger. So this is a time period of the trigger signal. T of the trigger should be greater than T of the pulse width. Assume that this is 2 millisecond, then this should be 5 millisecond. This should be like something like 0.2 millisecond. So that's what is the timings. So I have set some values. So I don't know exactly what are the values that I set. Okay, let me just find out. So the value of RT I'm setting is 10K. I think let me just make it 10K, and this CT is around 0.1 microfarad. So these are the values I'm setting. So let me go to this and then try to see. Let me run this. You can see now. Let me just go back to this trigger signal that I should give. So you can see I'm giving a trigger signal of 100 Hertz with a 50% duty cycle, and this is 2.5. So this should be 2.5 to ensure that okay, something like this happens. So this is what I'm looking at. If I give amplitude as 2.5 and offset as 2.5, I will actually get a waveform of 0 to 5 volts. So this is what is amplitude 2.5 and offset 2.5 stands for. So what I'm actually giving is a signal of what 100 hertz, 50% duty cycle, and something like this. So when it is 100 hertz, it is 10 millisecond. So actually what I have is, this is 5 millisecond, this is 5 millisecond. So this is what I'm having. So this is 5 millisecond, this is again 5 millisecond, this is again 5 millisecond. So this is what is the timing what I'm having as per this frequency and so on. So this is T trigger, or V trigger I will call it as. That is trigger signal. So let me see the corresponding output voltage, which you can see here. Let me just go back to this and go to this scope. Let me stop this. You can see I'm setting a range of 2 volt per division, and there is an offset of 2 volt given so that it is above and this is below. If you can see here, what I'll do, let me just give me a minute now. So let me just directly give the signal to 1 sec. So actually what I'm having is, I'm having a what is that? So let me just give it directly to this. So I'm giving it to pin number 2 here. Let me just give the same thing to pin number. Okay. Since I given it as what is this? This is what I given, 5 millisecond, 5 millisecond. Since my RT, let me just try to find out what is RT-CT. RT is 10K, and CT, I think it is 0.1 microfarad. As per this, RT-CT will be, okay, my T of the pulse width will be equal to 1.1 RT-CT, which will be 1.1 into 10K into 0.1 microfarad. This happens to be around 1.1 millisecond. So this is what is expected. If you can just go back and see here, you're not getting the expected waveform. You're not getting the expected waveform. Okay, as long as this is low, this is also coming as high. So why if you actually measure the pulse width now, so this is your actual output. Output has to be measured here when the output is high. So let me just go back and see the X cursors. If you just take one normal and one delta, if you measure between this and this, it will be exactly 5 millisecond. This is, now we can see this is 5 millisecond, which is not the expected one. So what I'll do, I'll just because I'm expecting close to 1.1 millisecond as the pulse width, but I'm getting it as 5 millisecond. It is purely because I have not adjusted this waveform, that trigger signal, to be of something like this. So this is the expected waveform. What I'll do is, I will just do it like this. So I will just apply waveform which is very small duration, low, and then this is now repeating. So this should be far less than 1.1 millisecond. So that I'll do here. What I'll do, I'll just go back to my wavegen and make the symmetry as hardly 5%. You can see I'm applying a trigger signal whose, sorry, my off time should be, let me make it 95%. Sorry, let me make it because off time should be as small as possible. So you can see I'm off time making very small. What I'll do, let me now go back to my scope. Let me run now. Now I'm getting it properly. See now? See, I'm applying a trigger signal. Let me just see it now. Let me take out this. Let me take out the cursors also to have a clarity. Where is, how do I remove? Let me just remove. Let me run this. Let me stop it. Now you can see. This is my trigger signal going low, and you can see it's going above quickly. That means my trigger signal is only this much. You can see this is the pulse width. So as soon as my trigger signal goes below VTL, output goes high and it stays for a predefined period of 1.1 RT-CT. In this case, it's 1.1 millisecond, or I don't know what the value of RT, so maybe 2. Maybe it's 20K. Let me just find out. I'm using the DRB. Let me actually take the cursor and measure it. It's X cursor. Let me take one normal, one delta. Let me measure the time. I think I'm using RT as 20k. I think it is 20k. Yes. So you can see now it is almost 1.96 millisecond. So actually what I'm having here is from the DRB it is not actually 10k. It's actually two divisions are there. It's actually 20k. So it is 20k, this is 20k, then this becomes 2.2 millisecond. This is the expected value. What you're getting here is almost 2 millisecond, almost 2 millisecond. So this is your trigger signal, this is your monoshot output. This is what is required. And suppose if you want to see the capacitor voltage, what I'll do is I'll just remove this pin number that is trigger signal here from my waveform observation. I'll go to my capacitor charging discharging of pin number where is RTCT? RTCT is at pin number 6 or 7. It's here now. I'll just run it. I'll stop it now, but I'll make both of them coincide at the same point. So I'll make this also as -5 so that it coincides. It's perfect. Now we can see this is the capacitor voltage. When the capacitor voltage reaches this point, which is actually, okay, let me make this 1 volt per division so that it is more clear. Let me make this also 1 volt per division. This is also clear. Let me make it 0 so that it is fine. This also, let me make it 0. Now it is perfect. You can see now the capacitor voltage is charging in the quasi stable condition. It goes till VTH. Once it goes to VTH, output goes down to 0. So this is your capacitor voltage and output voltage. So this way, if I just go back to my here, this is how your output. This is trigger. This is trigger. The output is something like this. Now output goes high. It stays there for a predefined period and then comes down, and it again goes for a predefined period. So meanwhile the capacitor voltage charges up to VTH and comes down. This is VTH. This is VCC. VCC need not be 5 volt. It can be 3 point. You can actually measure what the voltage. So where is that? Let me just go here. This is almost let me just give me. You can see it's almost 4.3 volts. So that's what is this. Theoretically speaking, this is not actually VCC. This is actually 4.3 volts. That's it. So if you can able to do this much, it's fine. Suppose if you use a LED here. So what you can do is you can simply put a LED here with a series resistor, current limiting resistor of around 220 ohm. So what you can do is you can use a switch here. You can use a 1K resistor and you can use a switch. When the switch is open, the LED will not be glowing. The moment you close the switch and then open it, of course, you just make it very momentarily. Make this RT value and CT value so large that this will be on for at least 1 second or 2 seconds. So that's a small modification that you can make it. So in such case, you are not applying any trigger signal from the wave gen. So it's this itself becomes the trigger signal. In the previous case, I actually given the trigger signal through wave gen. If you are using this switch type thing, so there is no question of trigger signal given from W1. So this 1K will pull your pin number 2 to VCC, which is something like this. When I actually close the switch, you are actually making a trigger signal, and of course you just make this and then remove it as soon as possible so that this glows for a predefined period of RTCT, which will be, of course, if you make it 10K and 0.1 microfarad, you may not see it. Make it 10K and 100 microfarad or 500 microfarad so that you can see LED will be on up to that much duration, which is in terms of seconds. I hope that will going to serve some purpose for your understanding of 555 timer. Thank you.